So this tutorial is entitled How to Use SQL Even If You've Never Written a Single Line of Code. And here's why we created this training series. And it's because as a company, we've seen that our clients are starting to accumulate and use more and more data. And what happens is that there gets to be a point in time where if you do not keep up with all the data that is being collected within your organization, and you don't keep up in terms of the tools and the techniques that are used to access and analyze the data, then it is very possible that you may fall behind if you are asked to complete a certain task and the data is going to come from a database, or it's going to come in a manner that you are not familiar with, or in a manner where it exceeds the capacity of Excel. And so the goal of this seminar is to actually get people comfortable to using SQL, because when people hear the term SQL or they look at SQL queries, a lot of people get nervous because they may not have written a single line of code in their life, and therefore they're not going to touch the technology. But as we've seen, SQL has huge utility within a business. We've seen it with our clients, we've seen it within our business, and if I can just sort of give someone an introduction into SQL in a way that's sort of non-confrontational and friendly, because of the coding side of it, then I think this seminar will do its job. So let's start. My name is Grant Aguinaldo. I'm a principal at Invera Consulting, and very simply, I solve current day problems using current day tools and techniques. And you can find more about me at grantaguinaldo.com. So this seminar will be in two parts. We'll have slides and we'll have a live coding part of it. The slide section is what you're seeing now. The live coding section is when I will go into a live SQL database. This is a toy database that was put out by MySQL. It's called the Sakila database, and it is a toy database of DVD sales from two DVD rental stores. It includes inventory, customer data, and sales data. And we will be working with that toy database in the second half of this seminar. But in this half, we'll be talking about slides, very high concepts to allow you to understand where the utility, or appreciate the utility with SQL, and give you some of the foundational concepts that you can build upon as we progress throughout the seminar, and then as you progress in the use or your use of SQL within your given situation. And so this part, or the slide deck part of the seminar, is actually going to be two parts, where we're going to talk about what is SQL, and then we're going to talk about how is SQL used in an actual workflow. And so we'll look at that in the second half. So what is SQL? SQL is actually an acronym that is pronounced SQL, but it's actually stands for the Structured Query Language, SQL. But in current day current day people talk about SQL, they just call it SQL. It's its own word, but know that it is an acronym. It stands for Structured Query Language, and that's precisely what it is, because it is a language that is used to query databases, and the way that you write your query is very structured, and we'll see in the next slide that it's so structured that it actually has its own standard. So it was developed in the 70s by the folks at IBM, and by far and large it's used to work with databases. Databases you can think of as being large thumb drives or large hard disks that reside on your company's network, or within your company's infrastructure, computing infrastructure, and it just stores data. It may store sales data, it may store customer data, it may store process data. The use cases are somewhat endless, but anytime you want to you want to store data somewhere, and you want to store large amounts of data, then uh, more often than not, a database will be involved because Excel has its limitations, and you don't want to be using Excel to be storing data because that's not what it was designed to do. It's sort of like fitting a round peg into a square hole. You could probably do it if you hit it hard enough, but it's not meant. Its primary functionality of Excel is not meant to be storing data. That is reserved for databases. Now, when you write SQL queries, you will write queries to access data to and from a database. Now, when I say access the data, it could either mean read access or write access, or in some very rare cases, you may have read-write access. What I mean by this is that read access means you will write queries to just view the data that is being stored in the database. You cannot modify it, you cannot erase it, you cannot update it, you just read it. On the other hand, some people will have write access, and in that case, you will write queries to write new data to the database. You could update, you could change, you can add, and that's generally reserved for select few people, namely database administrators, because if you grant write access to large amounts of people in the organization, large amounts of people can change the data, you actually start to compromise the integrity of the database itself. Therefore, write access is typically reserved for just a few people. However, read access is more more access is granted in more cases than write, and in very rare cases somebody will have read-write access. But generally, you will write queries to access data from a database, and you will be viewing data. And that's somewhat comforting because a lot of people worry that, well, I want to write a SQL query, I don't want to delete everything. Well, if you have read access, you can't do that. And so you just always want to be sure that you check with the network folks that you have what kind of access do you have. Most times it's going to be read only. So like I said, SQL is a standard language. It's a structured language. It's so structured and so standard that it was actually given a standard certification in 1986. However, that standard has been updated to include new features as sort of technology advances. Newer features have been considered to be part of the standard. All of these standards have been rolled in to the overall ANSI standard. Now, although there is a standard way of writing a SQL query, select from where, you'll see that in the second half, but every SQL query will have a select statement, which will be a select the columns from what table and then where, or how do you want to order it or display it. That general select from where structure is sort of the standard. However, even though it is standard, there is subtlety within that select statement that are going to be present within the different dialects within SQL. Now, a dialect is simply the specific type of SQL database that you are working with, and it can change. Three of the most common, and we'll talk about this in the next slide, are Postgres, MySQL, and MS SQL Server. Those three dialects are very common. However, there are subtle changes within each one, and because of those subtle changes, a different, a query that you write in one dialect for one database may not be 100% portable to the next one, i.e. some changes will be needed. And the most common example of this that I can think of is that in Postgres, or actually in MySQL, you always end your query with a semicolon. If that semicolon is not there, your query won't work. However, in Postgres, the semicolon is actually not needed. And so if you learn SQL in Postgres, depending how you learn it, the emphasis of the semicolon may or not be present. However, if you take that information or you take that exact query and go into MySQL, the query will not run. And so, i.e., that is one of the small changes that you need to port the query from one dialect to another. And that's important to know because it can be very frustrating if you cannot get your query to work. on another dialect of SQL, even though you, quote, you were taught SQL or you learned SQL. And so that's important to remember. So like I said, there are 3 common dialects of SQL: Postgres, MySQL, MySQL Server, Microsoft SQL Server. And generally in all the organizations that we've went into, the SQL database will be in one of these 3 dialects or flavors. And again, although the structure of how you write your SQL query within all of these 3 databases or these 3 dialects are the same, it starts with a select from where structure. There are subtle differences in each that will be needed for it to work. We just talked about the semicolon, and so it's up to you to research some of the subtleties if you are moving from one dialect to another, or you're moving back and forth. You need to keep that in mind. So again, that's another point to remember. So now we've talked about SQL, what is SQL, and the different types of dialects that are out there. Let's just talk about databases in general. Like I said, databases you can think of as being really, really large thumb drives or hard drives or hard disks that are present within your organization. Databases are organized collections of data. And like I said before, a lot of people store data in different formats, but generally databases are used to store data. And I say that because sometimes people think that Excel is used to store data. Now, it is possible to store some data in Excel. However, depending on the scale and the amount of the data that you are using and you are collecting and you need access to, it may not be the best tool for what you are trying to do. Databases are the primary function of the database is to store data. The primary function of an Excel sheet is to do calculations on data, and then it stores data second. And so that's very important to know, because databases are solely designed to store data. Excel, not so much. Now, the second thing is that when you start talking about databases and you talk about SQL databases, there is this discussion of relational versus non-relational databases. And I'm not going to get into the weeds about this, but I think for this seminar, I think you need to know, the most important thing I think you need to know is that relational databases or SQL databases are relational databases. Non-relational databases are referred to as non-SQL, NoSQL type of database. Now, the main difference is how the data is stored. For a relational database, the data will be stored in tables that will resemble Excel spreadsheets. I cannot say the same for a SQL database. One example is that a lot of times in a non-SQL database, the data is stored in a format that resembles a JSON or JavaScript object notation, which is a type of structure or organizational structure of organizing data so that it can be passed through the internet. That takes a little bit more computing and a little bit more knowledge in order to access data from a non-relational database because of the JSON structure. But when it comes to SQL, everything is stored in a table, and the table it resembles a database. And so that's the key difference. There are a lot of other ones, but for this seminar, that's all I'm going to ask you to know. And SQL is used for relational databases, and so we're going to be focusing on relational databases for the rest of this seminar. We're not going to talk about non-relational, non-SQL. We're not going to talk about that. However, I do encourage you to do some research online just to get some introduction to what they are. So the structure of a SQL database. Each SQL database is made up of one or more tables. Each table has one or more columns, and each table resembles a spreadsheet. It actually looks like an Excel spreadsheet. And what you'll find is that when we start to do the live coding section of this seminar, you'll see that the way that the data returns actually looks like a spreadsheet. So it's actually very user friendly. So each database is made up of tables. You can have one or more tables. The organization of a database is contained in the schema. This is important to understand because the way that databases are set up is that they're set up of, like I said, one or more tables, and each table is a logical grouping of information or data. So if you have, or so what you'll find in the Sequela database is that you have one data of all customers. It's all the customer data is there. Every customer has a different customer ID. Then in another database, you may find every purchase that a customer has made over their lifetime. So it'll be all of the purchase data. And then in the third database, you may have inventory. And then that may be broken down by store or region or location or zip code. But each table is going to be grouped logically. So you generally have customers, sales of the sales, and then you have inventory, and the list goes on and on and on. The organization of how the database is stored is actually very important, and it's contained in the schema. And asking for the schema of your database, folks, is actually very important, because when you write queries, you are accessing the information within the table, and the structure and the complexity of your query is going to be directly dependent on how the data is structured and stored and organized in your SQL database. And again, the only way to know that is by working with the data, being comfortable with the data, and then recognizing patterns. But you can find it in the schema, or you can ask the people who maintain the database to give you the structure. So contents of the database is next. So we talked about the structure. How is data stored in a database? Again, like I said, the data is stored in tables. The tables resemble Excel spreadsheets. Now, data can be stored in a variety of different ways. It can be integers, decimals, strings, dates. There's a whole list. And this is important to know, because how the data is stored is going to affect how you write your SQL query. And so you always want to know, you always want to ask, of the data types of the columns or the rows, or you want to understand the data types. And that's because there exist cases where visually what you see is a number. It'll be 10, 100, a million. But actually, if you try to do a computation of that number, a million divided by 100, you'll get an error. And in theory, it should work the way that you've written it, but you keep getting this error, and now you're frustrated. What's important to know is that sometimes integers, a million, can be stored as a string, not an integer. And this is tricky, because if you've written, you spend so much time writing your SQL query and it doesn't work, and then it doesn't work. You've looked at it for hours, and there is no reason why this thing can be wrong. It could be wrong for a very simple reason of you're trying to do math on a string, and that just doesn't work. So what happens is that you need to typecast it. You need to change the type from a string to an integer for this thing to work. And so again, those are subtle points that you get only when you start working with the data a lot and you understand the structure. But at the start, you really have to ask someone who maintains a database to really get to understand the structure at a very basic level first. Now, with that being said, let's talk about let's talk about the utility of databases. Databases have utility. The greatest utility of a database is because there's generally no limit as to how much data you can store in a database, aside from sort of the physical limits of the system that was put together that is housing the database. And that's important to know, because if you work with Excel kind of maxes out at 1 million to 1.4 million rows. And so if you have a data set that exceeds 1 million, you may not be able to work within an Excel. In addition to that, if you have a lot of rows in Excel and a lot of columns, Excel may be quite sluggish when responding to operations that you're writing in Excel. And so you want to know that, because if you're on the clock and time is money, you want to be sure that you're being as efficient as you can when it comes to working with the data. Because if it's not working because it's taking a while because Excel is maxing out, then you really have to think about you have to think about it, and you have to ask yourself, am I using the proper tool for the proper job? You always want to be using the proper tool for the proper job. And sometimes the proper tool for that job is going to be SQL. If you like it or not, it's going to be SQL, and you will need to dive into a SQL database. And so that's really the utility that I see with SQL, is that it allows you to work with large amounts of data in a more efficient way. And that efficient way is going to now complement a lot of your Excel skills, because if you have a lot of data in the database, you can query, you can reduce it down into a manageable size, and then bring it over from SQL to Excel, and then finish up your analysis that way. And that's going to be a really efficient use of your time, and a really good use, or that's going to be really good in the sense of that you were using the proper tool for the proper job. And so that's really the reason why that I enjoy SQL, and I see immense utility, or huge potential and utility in SQL. So that's sort of the end of the first part. In the second part, I'm going to talk about the SQL workflow, the data analytics workflow, and then after we get done with that, then we'll talk about, we'll jump into the live coding section. So I'll see you in section 2.